Welcome to this video on architecting expertise in large language models. We will explore a strategic guide to Retrieval-Augmented Generation, or RAG, and fine-tuning, focusing on connecting core models to external knowledge sources. Despite their size, foundation LLMs have blind spots. They are trained on general, static data, creating a knowledge gap in enterprise or dynamic use cases. Core issues include factual errors, outdated knowledge, and a lack of domain-specific context. To bridge this gap, we have two paths to domain mastery. Fine-tuning, or the scholar, embeds knowledge into the model's architecture. RAG, or the researcher, supplements the LLM by retrieving information from external dynamic sources without modifying the core model. Choosing an approach depends on your needs. The framework shows RAG connects to external data without core changes. Fine-tuning modifies the core model. Prompt engineering uses the model's inherent capabilities, and hybrid approaches combine them. Comparing RAG and fine-tuning, RAG uses external dynamic knowledge sources with real-time updates and is typically more cost-efficient and explainable. Fine-tuning internalizes knowledge, requires retraining for updates, and is more expensive with lower explainability. Naive RAG follows a simple retrieve-read framework: indexing, retrieval, and generation. However, it has inherent limitations, including low precision in retrieval, susceptibility to hallucinations with poor context, and difficulties reconciling content from multiple sources. We move from naive RAG to advanced and modular RAG systems. Advanced RAG adds pre-retrieval steps, like query rewriting, and post-retrieval steps, like re-ranking. Modular RAG uses an iterative cycle with components like search, routing, and memory. Optimizing retrieval means finding the needle in the haystack. Enhance semantic representations through strategies like recursive splits or the small-to-big method. Align queries and documents using query transformation techniques like hide or step-back prompting. To refine generation, move from raw context to coherent answers. Post-retrieval re-ranking addresses the lost-in-the-middle problem by reordering chunks. Context compression reduces noise and computational cost, helping the LLM focus on key information. Advanced augmentation includes iterative, recursive, and adaptive flows for complex problems. Iterative retrieval uses the output of one generation to inform the next. Recursive retrieval breaks a query into sub-questions. Adaptive retrieval actively decides when to retrieve. Evaluating RAG requires measuring two pillars: retrieval quality, or how good the context is, and generation quality, or how well the LLM uses that context. Key metrics include context relevance, answer faithfulness, and noise robustness. A growing ecosystem of open-source tools and standardized benchmarks exists to evaluate RAG. Key benchmarks include RGB and Recall. Open-source tools like RAGAS, ARES, and TrueLens provide frameworks for measuring faithfulness and relevance. Current challenges on the RAG frontier include the long context dilemma as context windows expand, requiring new methods for utilization. Robustness against noisy or adversarial information is crucial. Finally, production-ready engineering demands excellence in security and efficiency at scale. The future is hybrid and multimodal. Trend 1 involves the synergy of RAG and fine-tuning into hybrid strategies. Trend 2 is multimodal RAG, expanding beyond text to incorporate data types like images, audio, video, and code. The key takeaways are: start with a strategic choice between RAG, fine-tuning, or a hybrid approach. Embrace the RAG evolution by moving beyond naive RAG to advanced and modular techniques. Finally, obsess over evaluation to build production-ready systems.